Hi. So today we're going to be looking at like the first page of the mysteries, and it's kind of obvious to you that we're looking at the the Euclid's algorithm. So here, what we're simply doing is we're trying to compute the GCD of 67 and 24, and we're just doing this using the process. So we divide 67 by 24 as we would, and the quotient here is 2, and the remainder is 19, and that's why we get this. Then we divide 24 by 19, and the quotient here is 1. So, and the remainder will be 5. So, this is what we get. Again, we try dividing 19 by 5, and 5 3s are 15. So, we have 4 as the remainder, and 5 here. Then we divide 5 by 4, and that's so the quotient is 1. The remainder is also 1. And yeah, so now dividing 4 by 1 will just something like the remainder will be 0, and we just get 4. So we can just construct these equations from our repeated divisions and while following the GCD. So let's look at the second part here. So basically from these equations, we can like backtrack to writing 1 as some kind of sort of like uh, uh, linear combination, or linear combination might not be the right word, but some kind of like a constant into 67 plus some kind of constant into 24. And how we can do this is like also explained here, but also it's pretty easy to do it ourselves. So 1 can be written as 4 minus 5. Sorry, 1 can be written as 5 minus 4. And then we can write 4 in terms of 5 and 19. So 4 can be written as 19 minus this. So now simplifying this, we'll get minus 19 plus 4 times 5. Similar to 4, 5 can also be written as some constant into 19 and 24. So we'll say minus 19, 4 into 24 minus 15. And then we get 4 times 24 minus 5 times 19. Now we write 19 as a constant of 67 and 24. So 4 times 24 minus 5 times 67 minus 2 times 20. Minus 2 times 20. So let's do that. We get this minus so 1 is equal to 14 times 24 minus 5 times 67. So that's what we get here. Here. And this can be like done for any any uh, any number that any two numbers for the Euclidean algorithm, because we're eventually going to end up at end up at 1 and 0 here. So um, let's see. Let's see what we can do next. So this is 67 and 24 written up as a continuous fraction. And we can observe that these numbers that appear here in these brackets are also the quotients that we got above. They're also like right here. And we can observe that it's basically the first quotient plus 1 over the second quotient, because the first quotient here was 2, second quotient was 1 over the third quotient, which is 3. Get 3 plus 1 over the fourth quotient, which we recognize is 1 plus 1 over the fifth quotient, and our last quotient, which is 4. No more fractions after that. So that's it. And how are we getting to this? How can we construct this from just 67 over 24? So this is pretty like, so we use our first equation. So let's use our first equation, and I can just erase this. So let's use our first equation, 67, and divide this by 24 on both sides. So we get 2, it's 19 over 24. Now 19 over 24 can also be written as 1 over 24 over 19. So now this, we can just use a second equation like we did in the first equation. We can write that as, we can divide like both sides by 19 of the second equation. So then we get 24 over 19 is 1 plus 5 over 19. Then again, rewrite this as 1 plus 1 over 19 over 5. And then use the third equation. 2. All right, 19 over 5 is 3 plus 4 over 5. Again, now we use this equation, the fourth equation. But before that, let's rewrite 4 over 5 is 1 over 5 over 4. And then we can rewrite 5 over 4 as 1 plus, dividing both sides by 4 of this equation. 5 over 4 is 1 plus 1 over 4. So just rewrite this as 1 plus 1 over 4. And this is our GCD. So this is just where it terminates. We cannot go any further. So let's see. We've seen this and we see how we got to this. Realize this is some sort of like continuous fraction. And then the last part, I think, is kind of trying to get an approximation of this fraction. And so this just considers the 2 over 1. And then this kind of doesn't consider this part of our fraction. So this is 2 plus 1 over 1. And that's just 3 over 1. And that's how we get the second part. And then I think for the third part, they just ignore this term. So it becomes 2 plus 1 over 1 plus 1 over 3. We ignore this term. Maybe they decide it's too small, so we can just ignore it. So and then that would give us 4 over 3, right? And 1 this. So this is just 2 plus 3 over 4, and that's just 11 over 4. So this is how we got the next one. And then similar to that, we just decide to ignore this 1 over 4, and then it's like 2 plus 1 plus 1 over 3 plus 1 over 1. So this is something they do, and we get this sort of like get this thing 14 over 5. And then when we consider this 1 over 4, we get 67 over 24. And these are like less and less accurate as we go to this side, and this is like the actual fraction, I guess. Yeah, so if it were truly like just continuing and it doesn't end anywhere, which probably won't happen when we're like trying to find the GCD, maybe these fractions would give us sort of like an estimate what's the value, I guess. But yes, so this is like the last part in the first phase of the mysteries, which mainly like focuses on the Euclid's algorithm.